In this video, we're going to talk about the classification of matters by components. And I have this nice flow chart here that will help us classify matter. And so here we have matter in the middle. And essentially it could be broken up into two parts. It could be broken up into a mixture and a pure substance Now, if the mixture is uniform throughout, which means that you cannot tell a difference. Okay, so if it's uniform throughout, we call it homogeneous. Okay, now some people say homogeneous, it doesn't matter. Homogeneous, doesn't matter. But if it's uniform throughout, which means that it appears to be one thing, then we say that's homogeneous. Okay, now if it's not, it's heterogeneous. If it appears to be two things, then we would say that's heterogeneous. And we're going to talk about some examples here. Okay, now on the pure substance side, if they're separable into simpler substance, if that answer is yes, then we call that a compound. Okay. Now, if they cannot be, we call it an element. And so, what are some examples? Well, when we talk about elements that cannot be broken down further, okay, this is what we call elements. They cannot be broken down further into simpler substance. Helium gas would be one. Okay, that's an element that cannot be broken down into a simpler substance. How about carbon? C represents carbon. That's an element that cannot be broken down into a simpler substance. Okay, now for a compound, yes, it can be broken down into simpler substance. And an example of this would be water, H2O. Notice we have hydrogen and we have oxygen. Okay, so notice I could take those apart to get oxygen gas. Then I could take those apart to get oxygen and hydrogen gas. Okay, so that's the difference. Okay, if it can be broken down to simpler substance, then we call that a compound. If it cannot be, then we call that an element. Okay. Now on the mixture side, if it's uniform throughout, the answer is yes. That would be homogeneous. Okay, and so what is an example of homogeneous mixture? Well, that would be sweetened tea. Sweetened tea is a beautiful example because it appears to be one, which means that it's uniform throughout, but in fact it's made up of multiple things. And so in sweetened tea, which may just appear to be I don't know, brown, okay, we have sugar inside that has been dissolved, and we also have water. Okay, so we have all this stuff that combines to make everything looks like it's one, but in fact we have a variety of stuff in that. So that's what we classify as a homogeneous mixture if it's uniform throughout. Now if it's not, then we call it heterogeneous, and we're going to go into depth about what these mean. Okay, and an example of that would be if you have a beaker and you put water and sand in. So if I have a beaker and I put water and sand in it, it's going to be very clear that the sand will settle at the bottom and I'll have water at the top floating. Okay, and so notice that these mixtures it's not mixed throughout. Okay, and so you could definitely see the two differences. Okay, so that would be an example of a heterogeneous mixture. So let's break it down from a informational standpoint. So pure substance are only made up of one thing. Okay, mixture on the other end is made up of more than one thing. Okay, and so let's take a look at pure substance. Okay, so elements cannot be broken down further. Okay, we already talked about that. Helium is a prime example. Compounds are made up of two or more elements in fixed proportions, and so we say those can be broken down. Okay, like H2O, hydrogen and oxygen. Okay, now for mixture, let's look at homogeneous mixture, and we say these appear to be one, but in fact is made up of multiple things. An example of this would be, again, tea, sweetened tea. Okay, again, it's made up of sugar and water and all this stuff, but it appears to just be one pure substance. Okay, so that's a homogeneous mixture, and some of the properties for homogeneous mixtures that we should look for is they're miscible, which means that they will dissolve. Okay, and so that's why sweetened tea is a prime example, because we have sugar that's being dissolved in water to give us this beautiful pure one homogeneous mixture. And so these are miscible. Okay, and these are usually of a single phase. So notice that with the example of a sweetened tea, we only see liquid. Okay, the only state that's present is liquid. Okay, now they're inseparable by mechanical means. Okay, now what are mechanical means? Well, pouring could be one. Okay, so notice that I can't separate my tea by pouring it. I can't separate the sugar by pouring. Like it's impossible. Okay, because it's dissolved in it, so I cannot separate them by mechanical means. So what we mean, and these are equally distributed. So again, if they're equally distributed, then we have a pure substance. Again, everything is all together. Okay. Now for heterogeneous mixtures, the composition varies. Okay, and so we say that these are immiscible, which means that they won't dissolve. Okay, so these won't dissolve. Okay, these won't dissolve. Okay, and they're separable by mechanical means. So notice that our example of putting a beaker with sand and water. Notice that the sand will stay at the bottom and the water will float on top. Well, notice we have two different phases. We have a liquid, which will be the water on the top, and then we have the solid, which is the sand. Well, notice I could simply pour off the water to just leave the sand alone in the beaker. And so those are separable by mechanical means. Okay, and then again, obviously they're unequal distributed throughout. Okay, so again, maybe we have more water and less sand. Okay, these are not equally distributed, or else we would have a homogeneous mixture. And so these are the differences between the classification of matters.